Hello dosto, once again welcome back to the Tech CV Learning. Hope you have seen the previous video. That was really interesting, right? I have explained all these things very clearly, so that will be very interesting. Hope you have seen that video, so it will helpful in the today lectures, right? So without wasting time, let's start the series. Please watch the video till last. I promised you will surely going to understand the concepts. It's my promise to you. So let's understand the concept. So let's see. So in the today lectures we're going to design, right, axially loaded column, right? In the previous lectures we have already studied about the means what you call the classification of column based upon the types of loading. So the first loading is axially loaded column, and I have shown you where the axially loaded column is means what you call seen when it seems to be appear. I have given you one plan, right? In one plan, right, divided into different types of beam and inserted a columns. So these in this area a columns is subjected to axially loaded column, and I have shown you the reason. So please जाके जल्दी जल्दी वीडियो देख लीजिए, so it will be very helpful for you to understand. So चलिए समझते. Here to design the means what you call axially loaded columns, we need to design as it is a compression members. We need to find out the compressive force, that's PU. So compressive force is nothing but the means compressive means what you call stress into area. So as it is means column is subjected or column is of two material, that is steel and the concrete. So that one means stress of steel into area of steel plus stress of means what you call steel and the area of steel. So as you know my dear friends, means from the previous lectures in the flexure member itself, the means stress in the means what you call concrete is 0.446 FCK AC, right? AC is nothing but the area of concrete, 0.75 FY ASC, right? ASC is the means what you call area of steel in compressions. So we can say that 0.45, we can round it off. हम इसको राउंड ऑफ करके ऐसे लिख सकते हैं, यू कैन राइट इट एज 0.45 FCK AC, where AC is the area of concrete, plus 0.75 FY and ASC. So this is the formula can be used when the load passes through the midpoint. My dear friends, बहुत ही इंटरेस्टिंग होने वाला है ये सब्जेक्ट, राइट? बहुत ही इंटरेस्टिंग टॉपिक है, राइट? हेयर एज यू कैन सी टू फार्मूला, 0.45 FCK AC plus 0.75 FY ASC. At the same times you can see also here 0.4 FCK AC plus 0.67 FY ASC. So यहाँ पे दोनों में डिफरेंस क्या? What is the difference between these two formula? My dear friends, in this formula the code book or the designers did not कंसिडर मिनिमम इसेंट्रिसिटी. इस फॉर्मूला में मिनिमम इसेंट्रिसिटी कंसिडर किया ही नहीं है, जबकि मैं आपको बोला हूं आई हैव टोल्ड यू दैट वी मस्ट कंसिडर मिनिमम इसेंट्रिसिटी टू प्रिवेंट फ्रॉम द फेल्यूर. ठीक है? सो इन दिस कंडीशंस इट इज इन दिस फॉर्मूला द मिनिमम इसेंट्रिसिटी इज नॉट कंसिडर्स. At the same times in this formula the minimum eccentricity is considered. So mustly use this formula for the design of the column. So here means this formula we got, we multiply by 90% of the loading in the above formula, so we'll get these ones. So hope you understand the difference between these two formula. This formula is used as to prevent from the bending, as minimum eccentricity is considered in these ones. So if you multiply the above formula by 0.9 then you will get these ones. Now एक और क्वेश्चन जो आता है, ठीक है, किस किस जगह पे इसको इस्तेमाल करना है, एट व्हाट प्लेस वी यूज दिस फार्मूला एंड एट व्हाट प्लेस वी विल यूज द मींस व्हाट यू फर्स्ट फार्मूला. सो रिमेंबर, याद रहे, इफ ई मिनिमम इज लेस देन इक्वल टू 0.05 b देन यूज दिस फार्मूला. इफ ई मिनिमम इज लेस देन और इक्वल टू 0.005 b then use this formula, else it is greater than, then use the first equation formula, that is 0.45 FCK AC plus 0.75 वाला formula. ठीक है? and E minimum is given as LO by 500 plus B or D, right? It's depend B or D, it's depend upon the means what you call minimum eccentricity, it is in X axis or Y axis, right? Or else you can take it as 20 mm, right? So whichever is maximum we can take this one. So this one is the conditions. एक और सवाल आता है, एक और बहुत ही इंटरेस्टिंग है, one more interesting. So if E minimum is less than or equal to 0.05 b, then E minimum suppose we considers 20, right? So 20 is less than equal to 0.005. So if you consider the B value, B the least lateral dimensions, then it is greater than or equal to 400 mm. So my dear friends, याद रहे, in any column, if the size of the column is greater than 400 mm, then we must consider the formula of this one. So याद रहे, अगर if the B value is greater than 400, then we must consider minimum eccentricity. As per the code book, minimum eccentricity is considered in all the conditions. So now hope you understand all these concepts. अगर कुछ भी doubt है, you can put it in the comment sections or you can contact us directly. So let's design one column so that you can understand clearly. So we're going to design axially loaded short column. So before we design, we need to analyze the questions very carefully. So let's understand the questions very carefully. It's very easy, my dear friends, no need to afraid from these subjects. So let's design a column 4 meter long. A column is 4 meter long, restrained in positions and direction at both the ends. It is both the ends fixed. To carry the axial load is given 1600 kilonewtons. It is said that use M20 grade of concrete and Fe415 of steel. So first, as usual, we need to write the given data. So length of the column is given, axially load is given, FCK is given, Fy is given. So I have written some very easy steps. Just follow the steps step by step. You are going to understand. So my dear friends, in the questions effective length is not given. Question में effective length नहीं दिया हुआ है. So we are going to use the effective length very frequently. So first we need to calculate the effective length. So as per the effective length is given as it is fixed end, means it is fixed from both the end. I have told you from the IS code book 456. Let's see once again this one so that you can understand. Yes, my dear friends, from these ones we are in. So you can see here the 0.65 into L. So this one is the effective length calculation for the designations when the both ends are fixed. So from here we have taken, so we can calculate the effective length. So 0.65 into 4 is given as the unsupported length. So we got 2.6 as the effective length. It is given in page number 94 IS 456 code book. So आसानी से हम लोग effective length निकाल लिए. Let's calculate the ultimate load or the factor load. As factor load is equal to 0.15 into P. P the axially load. So it comes, we're going to design by considering 2400 kilonewtons. So it is nothing but the ultimate load, means up to this much load structures can withstand. इतना लोड जो हम लोग कॉलम डिजाइन कर रहे हैं वो इतना लोड सेटिस्फाई, इतना लोड का जो मीन्स ताकत होगा कॉलम को इतना सहना चाहिए. ठीक है. So P is equal to 2400. Let's means design this, means we need to find out the size of column and the size of column is not given. ठीक है. साइज ऑफ कॉलम नहीं दिया है तो हम लोग साइज ऑफ कॉलम निकालेंगे. सो माय डियर फ्रेंड्स, एज इट इज गिवन पेज नंबर 71, दैट इज, एंड वी आल्सो नो द 0.45 FCK, दैट इज एरिया ऑफ स्टील. माय डियर फ्रेंड्स, एरिया ऑफ स्टील दैट इज AC कैन बी आल्सो रिटेन एज ग्रॉस एरिया. AG इज नथिंग बट द ग्रॉस एरिया माइनस एरिया ऑफ स्टील. मान लीजिए कि कोई भी कॉलम में पूरा कॉलम का एरिया से अगर स्टील को हटा देंगे, इफ यू रिमूव द स्टील्स देन देयर विल बी ओनली कंक्रीट. सो दिस कैन बी रिटन एज AG minus ASC plus 0.65 FY ASC. It is given in page number 71. You can go means what you call IS 456 page number 71. You will find out this formula. So here we assumed 1% of steel. My dear friends, I have told you that the minimum percentage of steel is 0.8 to up to 4%, right? So you can assume between these two. You can assume 2.5%, right? याद रहे, for earthquake resisting design, we will always going to design by considering means percentage of steel greater than 2%, 2.4%, 2.5%. Sometimes it may be considered as 3% also. So as it is not means what you call earthquake resistance, we consider as it is 1%. So we will substitute. Pu value is given, that is 2400 into 10 to the power 3 in Newton, 0.44 into 20 FCK. AG minus, right, AG means gross area minus 1% of AG, that is area of steel we consider, plus 0.65 FY ASC, right. So 1% 1 by 100 AG plus 0.67 into 415 into ASC. Here also 1% of AG we just remove ASC as the 1% of AG. So if you substitute, right, means AG minus 0.001 plus if you do calculation this ones, it comes 2.7805. so we find out from here, we find out AG, that is 208877 mm square. If you do the root under of these ones, then we'll get the value of 547. so we'll take the round of 500 into 500. so from here we हम लोग यहाँ पे एक मीन्स आइडिया आ गया, we got an idea that the column size should be 500 into 500, right, as it is a square column. We're going to design it is a square column, right. So from here we got the size of the column. So let's check whether it is long column or short column. ये समझना बहुत ही जरूरी है. It is very important to know whether it is long column or short columns. So for that once it is given as if L by B, right, we know that the effective length to least lateral dimension, I have told you in the first lecture itself, if it is less than 12 then it is short, if it is greater than 12 then it is long. So here come 5.2, of course it is less than 12, then क्या है ये short column है. बहुत ही आसान है, ठीक है. चलिए नेक्स्ट देखते हैं. Now I have told you that we must consider minimum eccentricity, right, whether it is means what you call whether the means bending moment is acting or not. यहाँ पे अगर बेंडिंग मोमेंट लग रहा है या नहीं, वी डोंट मैटर्स दैट वंस, बट वी हैव टू कंसिडर मिनिमम इसेंट्रिसिटी टू प्रिवेंट फ्रॉम द फेल्यूर, right. Either it is axially or means what you call axially with minimum, what you call axially with bending moment, biaxially bending or uniaxially bending. As it is uniaxially loading, although we have to consider minimum eccentricity. So E minimum is given in the page number 42 of IS code book 456 2000. You can go, you'll find this formula L by 500, while L is the unsupported length. So 4000 we calculated, divided by 500 plus D is nothing but the depth of the column 500 by 30. We got 24.6 and one more is that is 20. So whichever is greater we will take that value. So we will take 24.67 value. So we calculate minimum eccentricity. Let's now design the longitudinal reinforcement. So ASC we consider how much 1%. So let's check whether it is means whatever we consider, जो हम लोग consider किए वो सही है कि नहीं, ठीक है. Now we will going to design so how many numbers of bar required, right, कितना बार उसमें लगने वाला है, ठीक है. All those things we will going to calculate. So means it's very easy my dear friends. So as it is 1% of AG, to 1 by 100 into AG. Here AG we already calculated, right, in the previous numericals, right. So AG will substitute its value, we got this one. So means will as this one is the means what you call area of steel reinforcement. So we assume we are going to insert 20 mm dia of bar. We assume it, you can assume it 25, you can assume it 22, right. So as the AST, small AST will calculate, that is means pi by 4 into 20. So we got 314.5159 mm squares. So number of bar will be capital ASC divided by small AST. So we got 8 numbers. So we always take even number of bars. In column we can't substitute odd number of bar. आप लोग यूं ही समझ सकते हैं कि कॉलम में कैसे odd number of bar को रखा जाता है. We can't. So we always substitute even number of bars. So if it is, we'll consider 8 number of bars. So we'll provide 8 number of 20 mm dia of bar in the longitudinal sections. Let's check whether this one is correct or not. So there is a check, that is ASC max 4% of AG. We consider this formula is given in page number 48 IS code book 456. अगर अब भी आपके पास है तो जल्दी से पलटा के चेक कीजिए, प्लीज चेक इट, यू विल फाइंड आउट दिस फॉर्मूला. So 4% of AG, 4 divided by 100 into AG is 500 into 500, its area is given, so it is 10,000 mm square. Now ASC minimum I have already told you in the means IS code recommendation only, that is 0.8% of AG, so it is 2000 mm square. So condition satisfy, condition lie within the limitations, right. So here it is means conditions is satisfying within the valid portions. So now here we are going to design lateral tiles, and that is transverse reinforcement. So for the transverse reinforcement, the diameter of the transverse, जो चूड़ी होता है ना, चूड़ी, उसी को बोला जाता है lateral tiles. तो तो जो चूड़ी होता है उसका डायमीटर शुड नॉट बी लेस देन दैट वन 1/4 ऑफ द लार्जेस्ट डायमीटर ऑफ द लॉन्गिट्यूडनल बार, दैट इज 1/4 of the diameter of the longitudinal bar. So 1/4 into 20, as 20 is considered as the diameter of bar, so of course 5 mm and the 5 mm, so we should not consider less than this ones, so we will go greater than this one, that is 6 mm. In some code book here it is given as 6 mm, so we should take always greater than this ones, either 6 mm, right. We should not take less than 5 mm, we can take it 8 mm, right, depending upon the designs and the requirement. So this will provide 6 mm dia of lateral tiles. So now consider spacing, right. Spacing is also known as pitch. I have already told you in the first lecture itself. So pitch जो होगा वो कम नहीं होना चाहिए इस वैल्यू से, right. The pitch value should not be less than this ones, that is least lateral dimension is 500, that is B 500, 60 into diameter of bar, that is 60 into 20 320, and that 300 mm. So we should always consider least of these any 3. So least is 300, so we'll consider 300. So we'll provide 6 mm of lateral tiles at the rate 300 center to center. So you can see, my dear friend, this is cross sections. So this one is a column, right, as you can see. This one is the top view. So this one is a column. Here means how many 8 number of bar is inserted. This bar is of 20 mm diameter, and this one is a churi. This one is the lateral tile, 6 mm dia, 300 mm center to center. So overall depth is 500, 40 mm clear cover is provided. Its width and depth is 500 mm. If you see the longitudinal view, you can see this one's 3 reinforcement, 3 reinforcement, 2 reinforcements. This one is a churi, right. So hope you understand these lectures very clearly, my dear friends. Please don't forget to subscribe my channel. So hope you understand. Thank you. Bye bye. Take care.